Hi, everyone. I am not Reed. I am, one more click, Megan. Reed got stuck due to weather issues, so I am presenting his slides. I just got a copy of these slides last night at 11:30, so if it seems a little rough, that's why. But I'll be here to talk about the Charliecloud project update. Just for some context about me, I was the Charliecloud developer starting in 2020, and then switched over, so now I do more user support role, but still interact with the Charliecloud project a lot with user support things. Ooh, wait. Cool. So Reed likes to start all of his presentations with photos of everyone currently working on the Charliecloud project and folks working in the past. So if you see me, Angelica, Reed, whenever he gets here, feel free to ask us Charliecloud questions. So here is the agenda. So first I'll go into kind of what Charliecloud is, what you should care, also trying to hype up some of our presentations we have on Wednesday. So this is very high level. If you want to go more into the weeds, come to our talks later this week. We'll also get into our goals since last HPSF conference and our goals for the upcoming year. So Charliecloud. So what is Charliecloud? It is not a guy named Charles Cloud. He did steal the GitHub link, Charliecloud, so that's why ours is not that. But Charliecloud is just a lightweight, fully unprivileged open source container implementation made specifically for HPC. Want to point out the spelling, because I'm still getting emails with the incorrect spelling and capitalization. Charliecloud, all one word, just the first C is capitalized. And Charliecloud supports the entire container workflow, so building images, pushing and pulling to container registries, and also dealing with accelerators like GPU, which will be a common theme you'll see with Charliecloud content this upcoming week with the shift of being able to support AI workflows. We also have a unique approach to containerization and remain compatible where it matters. So when we say have a unique approach, we try to explore parts of the solution space that others don't. So we put our emphasis on unprivileged build and our build cache, which is pretty cool being Git-based. And remain compatible where it matters. This is mostly means OCI. Reed's pretty salty about OCI, but I'll get to his little summary slide later. So what is Charliecloud's different components? So there is currently 3 main Charliecloud components. The first one is chrun, that's written in C, and that's the container runtime itself. Then we have chimage, which is written in Python, and that's our Docker interpreter, also known as our builder, and that allows you to push, pull, build, all that fun stuff with containers. Then everything else kind of falls into this glue category, which is written in POSIX-SH, and this is our image converter and various helper scripts. But coming soon, I don't know, hopefully this week, we'll have a new component, which is chcompose, that Angelica is currently working on. That'll be in our next version release. That's written in Python, and this will be Charliecloud's kind of equivalent tool to Docker Compose. We'll talk about that more in upcoming slides, and Angelica will go more into the weeds about why it's super, super cool in her talk on Thursday, I think. Also, we currently have a working prototype for chrun, which is the Kubernetes runtime equivalent. And all of this lines of code is only 11,000, so take that as you will. And it doesn't use Go. I don't remember why Reed thought that was important to include. Okay, so philosophies at Charliecloud. So there's 3 main philosophies. If you've ever been to a Charliecloud talk, you've probably seen this exact slide 18 million times before. But the main philosophies are we are transparent, not opaque. So we think things should be explicit. Also think things should be simple, not complex. Containers are just processes. And also be unprivileged, which is the coolest thing about Charliecloud. We mainly do that because writing privileged code is tricky and difficult and super stressful, and nobody wants to go into a privileged code area at all. So here's a list of our key distinctions. So why is Charliecloud really cool and why you should use it? So the first one is Charliecloud's fully unprivileged from end to end. So you're unprivileged with run and build. And those were both industry first. Obviously now more container runtimes are implementing their own iteration. But we're the first, so that's cool. Also, in our opinion, our root emulation is best in class. I think what makes it really cool is we're constantly researching, trying to figure out what the next best solution is. So I think started with fake root, now we're on root emulation. It's very cool. I'm also willing to think outside the box. So, example, layers aren't fundamental. RC is garbage collected. We also adopt new Linux features before they were cool. So, user namespace being the big one. We also work with Unix traditions, not against them. So we make each process do one thing well. And we also have a very focused mission and philosophy on science applications to have lower technical and usability overhead. So this is a very high-level slide. If you want to get more into the weeds, come to Reed's talk on Wednesday. But this is his summary of why he's salty about OCI. So first off, assumptions clash with HPC. So usage, process, privilege, architecture models. There's also some design flaws in his opinion. TAR is a bad diff format, supervisor process assumptions. Is the distribution spec even needed? And the Docker file is not standardized. The last one is just plain old errors and bugs in his opinion. So different layer hashes in different places, symbiotic and hard links, behavior underspecified. Again, this is very, very high level. Want to get into the weeds, ask lots of questions, come to Reed's talk on Wednesday at 1:45. Cool, now we'll get into recent accomplishments. The picture on the right is the kid from that meme, but currently at age 20. Reed thought that was really funny when he found that out. So, recent accomplishments. Our governance and workflows. So there's a big push with the help of HPSF to get our governance and workflows more standardized. So in release 4.1 or 0.41, we added a code of conduct and a governance model. We also added a workflow quick reference to better help developers who want to get started with Charliecloud. And I guess more information on that Wednesday at 14:25. CDI, Container Device Interface. This one is very, very cool. Lots and lots of users that I've talked to have been really excited about this new feature, but this was released in 0.40, and this is the emerging standard for device injections, in which Charliecloud participates in. So currently in Charliecloud code, it is used for NVIDIA host injections. So all of our GPU AI workflows are forced to use this. Here's a very high level how it works. So let's just say we are on this GPU. We would try to run this container without doing any extra setup steps. You will get an error. This one is a CUDA error because can't find CUDA get device count. And that error message is pain because nothing runs and you can't do anything about it. So the present solution currently is to inject certain GPU libraries inside the container. So the first option is OCI hooks, which is defined by a JSON config file, which has command line program and arguments, run and don't run conditions. Let's see, hook programs get a JSON state blob on standard in. Reed had to reverse engineer this. Notably, OCI bundle path to config.json to image root path. That's too complicated. Hook programs then just does whatever it wants. With this quote, just run this opaque vendor program on every container start. Not a fan. OCI assumptions are just deeply baked. So let's get into our way better, cooler solution, CDI. So now, kind of the steps to get this workflow running is first you have to create a CDI.json file, which is pretty easy. You can just run NVIDIA CDK CDI generate. And then from there, you can look at the file. And then all you have to do is include a -d flag in your chrun command, and it does all the NVIDIA host injections for you. So in theory, from a user's perspective, they don't really need to understand the nitty-gritty details of what's going on, but now it works. Yeah, so you can see here, GPU, pass, happy output. And very nice admins should, in theory, do the CDI.json for you. I've done it for the modules that I own, made CVM do it 18 million times. So nice admins should do it. It's not too horrible. Yeah, and that -d flag just says, give me all the CDI resources. And CDI is descriptive, not procedural, so it's a very clunky .json file, but it makes sense when you read it. Cool. Yes, and also in release 0.4.0, we had C refactoring, including garbage collection. So you can see here, there we go. So we have our new malloc _ch. _ch means it's the Charliecloud version of malloc. And what makes it interesting is you have if-defs. So if we have libgc linked, we will allocate an arbitrary buffer and then buffer without pointers. If there's no GC, just use regular malloc. Yes, and those undef and defines just prevents running malloc by mistake. This is kind of based on this conservative garbage collector, which leaks it all. Yeah, this is Reed's kind of bread and butter. So if you have more questions, definitely find him when he gets in, if the weather works out. Okay, command and entry point. This, very exciting. So this was added in our most recent release of 0.43. Angelica will go more into the weeds on this on Thursday at 11:25. And these instructions particularly were highly requested by our user community. For like 2 years straight, every phone call I got about Charliecloud was, when will you get entry point? Now we do. So here's just to kind of high level explain how it works. We have this Docker file that's from Alpine. Then we have an entry point or instruction with echo hello, and then a command instruction with world. And now if we build and run some image with echo Rick Astley, you can see here it runs Rick Astley. But if you run that same container with a little dash instead of an actual command, and that hyphen is just the Unix for give me the default thing. Did it not show the output? Ah. This is Reed's fault for making me learn how to use Keynote. Oh yeah, it said hello world, just leave. Yeah, hello world, okay. And it kind of, you can see that ran from the entry point instruction. There we go, okay. So, command to entry point is, the logic behind it's a bit confusing. So you can see here we have an entry point, echo hello, $2, and then command world, build sand image, and this time when we run, it runs hello world. And is that confusing? Yes. Angelica will talk about it more on Thursday. So it's kind of funky, the logic behind it, but Angelica will talk about it more on Thursday. Okay, Docker Compose. This was another key feature that users asked about, specifically because NVIDIA workflows use Docker Compose for lots of different things, and we needed a solution to work with Charliecloud. So here is an example Docker Compose .yaml file. You can see here we have 2 containers in this workflow. We have container 1, that's Alpine, and the image is Alpine 3.17, and we have the command here that runs. So this is instead of entry point and command. And depends on if we want it to start after the Debian container. And once this is fully merged and in production, you'll see you'd be able to run chcompose, just list the YAML file, and then it will run as expected. Before this goes into production, there is a workaround. It's just clunky, ugly, and horrible, and no user wants to use that. So just to briefly go through a couple new things. So we have a new website which was released in 0.40, which has multi-version documentation in case you want to have some version control when looking at the docs. We also created a new install guide for newbies on our wiki, which was released in 0.41. It was mostly to help us onboard students, but can be used for anyone in the community. We also have multi-threaded fuse loops that was merged in release 0.44, which should give performance improvements. FIPS mode, Python works in 0.41, and then in 0.43, chrun signal masks are more explicit. So that makes newer Slurm happy. Cool, lastly, we have near-term goals. So what's gonna happen in this next year? First big thing, container build in difficult environments. This is mostly due to the new usage of AI and GPU workflows. So we have the rules we know and love, so internet constraints, including just plain not being available. We want to keep the unprivileged workflow, with root emulation being cooler. There's also some new file system quirks, with persistence and performance kind of having a trade-off. The big one is NVIDIA now has ginormous images that just take so long to pull and save and move around with. So we're working to get that better. We're also thinking of a Dockerfile extension with commit. Another one is with serverless image registry. I'll just kind of go through this. Basically, we want to make container registries easier, more straightforward. Cool, and we also want to add some other things. So we want to integrate the ArcSpec library to have better architecture inclusion. Also want to create a libcharliecloud to give good unprivileged containerization via C API. Also want containers for Apple computers. Want better SPAC containerization without loading any extra environments. Also want to finish and merge. We have 2 merge requests to run OCI bundles and CIF files. Also, we want to work on importing and exporting OCI images. Internal, better CI, better test suite, documentation API, REST, fixing all the bugs. The end. Okay, I don't know if we have time for questions, but that's it. Is there any questions before I leave? Yeah? Just talk loud, I guess.
Yeah, okay. Can you talk a bit about adoption and, like, in particular at Los Alamos, are you guys deploying Charlie? Is there any plans to, like, deploy it as kind of a default way of doing things on your HPC clusters, etc.?
So do you mean like default, like when a user starts a job, they're automatically in a Charliecloud job, or having it be the default container runtime?
What's your, you know, is there any plans to, like, on the big platforms, right, like, to use this as kind of a default mechanism, or at least say,
yeah.
Alamos people would deploy their software, right?
Yes, so currently Charliecloud's the only container runtime allowed at LANL, and slowly more and more projects, code teams are using containers because they're sick and tired of figuring out all the dependencies. There has been lots of chatter of how to incorporate this more at a production level. So maybe having the starting environment just be a Charliecloud or even just any container. I think with the push of AI and the new user needs, containers are a much better solution than what we're currently doing. So it would not surprise me to see kind of containers and Charliecloud used more in-depthly. But I'll talk about kind of user support needs and stuff about Charliecloud on Wednesday, if you're more curious about that.